Oi, gente. Boa tarde. Queria dar boas-vindas ao Philip Wadler, que vai apresentar The Two Cultures of Artificial Intelligence. Antes, ele vai fazer um pitch para conquistar alunos para a Universidade de Edimburgo. O Philip é professor da Universidade de Edimburgo, ele é fellow da Royal Society, fellow da ACM, e, para mim, é a coisa de longe mais importante, é um dos principais projetistas da linguagem Haskell. Então, Felipe, por favor.
Obrigado. Boa tarde.
Boa tarde.
Desculpa, eu não falo português. Vamos com perguntas. So I'm going to give a pitch. I just learned a new Portuguese word, pitch. The reason I'm giving a pitch is I'd like to attract some of you to be interested in doing some of your schooling at the University of Edinburgh. So let me just check. Is there anybody here who's an undergraduate who might want to do master's study at Edinburgh? No one. Are you guys all? So what level are you? Undergraduate? Hands up. No. Masters. They're all masters.
Graduate.
Sorry?
Graduate.
Gra-
What question?
Especialização.
Okay. So you're already doing a master's. Would anybody like to do a doctorate at the University of Edinburgh, perhaps? Okay, so now I know who my focus audience is. So there are two very good reasons why we want you to come to the University of Edinburgh. One of which I think is a good reason, and the other of which you may or may not think is a good reason. So one reason is we want the very best people in the world. Edinburgh is actually prestigious enough that we have a chance of attracting the very best people in the world. That's one reason. The other reason, which I think is not a good reason, and in fact is a very poor choice, is we charge more for students from overseas. But we have an exchange program with PUC-Rio. We have various scholarship programs. So this shouldn't be an issue for you, right? If you're very good, you can get a scholarship. If you're very good, that's exactly why I want you to come. So if I want you to come, you should be able to get a scholarship, and money shouldn't be an issue. The reason, by the way, that I think that's a very poor decision is we want the very best people in the world. So by discriminating against people from overseas, I think we're working against attracting the best people. So I apologize for that policy. But it does mean that my university is very keen for me to try to attract you, which is great. So let's tell you a little bit about the University of Edinburgh. And my phone got time, especially since we started late. Okay. It's quite old, 1583. When was PUC founded?
It's 53, 56.
19, right. Just in the last century.
19 is implicit.
So this actually makes us, I think, the fourth oldest university just in Scotland. Right? There are three others that are older, but we're still quite old and distinguished. As you can see from our nice old and distinguished building. We're quite large, about 45,000 students, about 5,500 staff. And there are all sorts of ranking systems. So I think there was one recently where we came in 15 and so on, but we're consistently in the top 50. PUC probably is as well. Is that true?
Maybe in the Latin America one, but I'm not sure if in the world.
No, Latin America, we are
Yeah, we're good
better
in Latin
than
America.
50.
Okay, so as you guys are to Latin America, we are to the world.
Yeah.
So this is the building I work in and that you would work in, the School of Informatics. That's what the inside of it looks like. They've just built us a new building across the way, which is the Bay Center, which also looks very nice on the inside. And this is mainly for commercialization. So we have a lot of relationships with industry. And it's particularly, does everybody know who the Reverend Baines is? He came up with an important law of probability theory. And basically the reason that this building is there is that the city of Edinburgh wants to invest in technology, invest in technology companies and so on. So that's why this is there. So we've got so for informatics, as opposed to the University of Edinburgh, so I should say that within the University of Edinburgh, informatics is either the strongest or second strongest department. So, you know, if the whole thing is in the top 50, we're above that. We used to be very obviously the best in the UK. They do a rating every 7 years, which absorbs a lot of energy from the various academic departments. But we used to consistently come in top on all rankings. We do not come in top on all rankings. If you pick your ranking, like amount of research, yes, we are on the top. But we're certainly in the top. The top, I don't know how they rank relative to each other, but Cambridge, Oxford, Imperial, and Edinburgh would be the ones at the top. So we've got 450 staff, 1,700 students. So, right, this is the top. We have the most research power in the UK. We've had lots of startups and spin-outs, and we have a team dedicated to creating more of those, our commercialization team. So, you know, there are all sorts of reasons that you can get. The important reasons are the people. So let me talk about some of the people there. So this is Robin Milner, who founded the bit of the school that I'm in. He's one of the founders of informatics, and he's a Turing Award winner. As Roberto mentioned, I'm lucky enough to be a fellow of the Royal Society. They just inducted me recently. It's an amazing thing because when they induct you, you have to sign this book. Who else signed this book? Robin Milner, Alan Turing, Charles Darwin, and Isaac Newton. So they, you know, when they show you the book and they say, look, this is where Isaac Newton signed, and you can see his name, but you cannot see the name of the person underneath it because everybody's pointed and said, look, this is where. So we in fact have 6 fellows of the Royal Society. Robin Milner founded the school, but he's no longer there. Unfortunately, he died a few years ago. I actually hold the chair he used to hold. So we've got 6 fellows, including me. But the thing is, it's quite a strong school. And interestingly, most of those people are in programming language design, which is what Roberto and I do. But in fact, the school is very, very well known for its work in artificial intelligence. What subjects are you guys interested in? Are you programming language people or AI people?
AI, might be.
Yeah, so everybody's an AI person. So who's AI? Who's PL? Programming languages? And what are the rest of you?
Distributed systems.
Distributed systems, that's very important.
Databases.
Also very important. So Peter and Len Fire are both known for their work in databases. Alan is known for his work in artificial intelligence. And then this is our head of school, Ellen Hasty. Jane there is our former head of school. We also do very well in teaching awards. So if you're doing a PhD, you don't do that much teaching, but you can see that we have lots of people that either get nominated for. The first 3 people were all shortlisted in 2020. Shortlist is sort of weird, right? It makes it say, you know, it's like in the academy, you're 1 of 5 or 1 of 10. No, it's a shortlist of 2. So these are all the people who were runner-up. We almost got it, but not quite. And that includes a course that I teach. I was very happy about that. And then in 2022, Fiona, who teaches second half of our first year course in Java, she got Teacher of the Year. So we regularly get people nominated for or shortlisted for or winning these awards. And we're very international. We have people from all over the world there. And oh yes, look, there is a Brazilian flag. So I think nobody here is interested in master's program. I can sort of skip over that.
I think there's one.
Yeah.
Okay, so 2. Okay. We have a master's programs. There are quite a few different subjects that you can pick. As you can see, AI is one, computer science is one, data science is one, people interested in databases, and so on. And then you can do things in all sorts of topics. When you do one, you end up writing a dissertation, a master's dissertation. So it's a one-year program. And these are some of the different master's dissertations you can get to. You've got things interacting with biology, video tracking of Drosophila, melanogaster, grammatics, behavior. Controlling a robot in a virtual world with AI planning, and so on. I'm not going to read all of these, but the point is there's a huge variety of things that you can do. And the basic program structure is you do 60 credits. So it would be 3 top courses, each of about 2 or 3 lectures a week. For the first semester, same for the second semester. And then during this time, you're also doing a literature review to prepare for your dissertation project. So you've already picked a dissertation project and met with your supervisor. And then over the summer, you do your dissertation project, working very closely with your supervisor. And oh yeah, I put this at the bottom because it's important. We do expect if you take the course that you already have a basic level of programming knowledge. So there are some courses to advance that further, but you are expected coming in knowing how to program. And then we have our research programs as doctorate degrees. So let's see, there's some more material here. So if you're going to do a doctorate degree, right, you want to know that we're at the forefront of research. So guess what? We're at the forefront of research. So we just founded a generative AI library. I'll be talking in my second talk about ChatGPT. That's an example of generative AI. So the very latest flavor, we just got lab in. We have 3 doctoral training centers in artificial intelligence. And yep, they have funding, including for overseas students. If you want to do AI, there are lots of different ways you can go. We have the National Quantum Computing Center. We have a new supercomputing center that's just being built. We have a blockchain technology laboratory. I actually consult for that. And we just celebrated 60 years of artificial intelligence and computing in Edinburgh. So we're one of the oldest places in the UK and in the world for doing this kind of research. So this is the important thing. So these, I should just point to it's okay if I stand up from that?
Yes.
Okay. So these are our 6 institutes. So we have one for AI, one for language cognition and computation. So that overlaps quite a bit with parts of artificial intelligence. Laboratory for foundations of computer science. So that would be databases and distributed systems and programming languages. The Institute for Perception, Action, Behavior. So these 3 all really do AI. We have 3 institutes that do that. The Institute for Computing Systems Architecture, so that's hardware design and compiler design to run efficiently on the hardware. And then the Institute for Adaptive and Neural Computation. There are 4 that more or less overlap with AI in various ways. And then the other 2 do real computing. And then what's very important, right, is all this other stuff. But what we proved is that the people who make slides for us can't work out how to make an oval large enough for the words to fit in properly. But the point is, well, we have a rather weird name at Edinburgh. It's called the School of Informatics. And there are two reasons for that. One is that computer science is not really a good name. There are only two things wrong with the name computer science: the word computer and the word science. Right? So why is this a mistake? Well, it's not really about computers. It's been pointed out that calling it computer science is like calling astronomy telescope science. So what we're really about is what the computers let you find out in terms of patterns of information. And it's bad to have science in your name, because if you're a real science, you don't stick science in your name, right? We don't say physics science, we don't say chemistry science. So it's much better, I think, to just have a name. So that's what informatics is. But also the name informatics is coined to have a connotation of this is about the interaction between computing and its impact on all these other fields. So very much it's possible to do an interdisciplinary degree if that's the sort of thing that interests you. So, very importantly, the UK government has decided the right way to do a PhD is that you have a center for it. So this is great if you've got the center. It's not so good if you don't have a relative center, because then you're not supposed to have any PhD students. And that means that there are many excellent researchers who are being underused. So there are other ways of getting a PhD funded, but it's by far easiest to do it in one of these centers. And if you're in one of these centers, so if any of these are subjects of interest to you, that means that not only is there funding available, but also that when you take your degree, you're in a cohort of other people saying similar things, you reinforce each other. So we've got one in AI for biomedical innovation, one on designing responsible natural language processing, one on quantum computing, one on machine learning, and one on dependable and deployable AI for robotics. So especially if you're interested in these subjects, there's a lot of support. If you're not interested in one of these subjects, then what you do is you say, well, who at Edinburgh is doing what I'm interested in? If there's not somebody, well, I think there will be somebody there, but there's not somebody there, then we're not a good choice for you. And if there is somebody that you're interested in, just write to them. Say, look, this is what I'm interested in. Be very, very importantly, right? Read their webpage first, write to them what you're interested in, and write to show that you understand how that intersects with what they're interested in. Basically, I get zillions of letters from people saying, hi, here's my CV. Do you want me as a PhD student? I send them that, a pointer to my webpage that says, if you send me something like that, I will treat it as junk mail. But I'm very happy and excited on the rare times I get a letter from somebody who shows that they know what they're talking about and shows that they're writing to me for a reason. So that's all you need to do. Just a couple of paragraphs to explain what you're interested in and that you know how to overlap with what they're interested in. And then they'll be in touch with you, work out where to go from there. And they'll give you lots of support in terms of how you apply for the degree and so on. I won't go through all the details now, but if you want to go, then there's a whole webpage that says, here are all the different scholarships we have when the deadlines are. So the next set of deadlines, there will be one towards the end of December, one towards the beginning of February, I think. So you want to get started before September, talking to people so you're all ready to go before the deadline in December. PhD students are by far the largest group of people and the most important group of people in the school, right? They're the ones who do the real work. We've got a huge number and 67 different nationalities. There's a huge thriving community of PhD students. So as I said, if you're in one of the CDTs, you have people working in subjects very close to you, but regardless, you'll be surrounded by lots of other students doing interesting stuff. Of course, the whole point is to meet them and do stuff with them and form societies and so on. And all of that happens. And right, there's a huge range of opportunities and other things to do, including most of our PhD students will do an internship at some commercial firm at some point. They go on Microsoft or Google or Facebook or what have you. So all of those these are supported. Right, we want the best in the world. So you need to be a strong student, at least a 2-1, preferably a first and a C distinction. There will be funding for about 45 places on the different scholarships. And they vary a lot. There's some on very specific areas, some from left-handed people belonging to a certain religion or what have you. But you can just go through the page and see what applies to you. So the link is here. I guess we can send that out if anybody is interested. Also, right, if you have any questions, you can ask me now or write to me later. And most importantly, right, if you type in WADLER, that will get you to my webpage, which will get you my email. So just send me any questions you have, and I can send you that link if you haven't memorized it. And in fact, recently we've actually put our stipends up a little bit, above inflation increase. And all of our funded studentships pay these stipends. So you will be supported, which is exactly how it should be. Like, you're very valuable so that you get paid enough that you can live and your degree is paid, covered by the scholarship. So here's where you go to apply, and then this is the steps that I think I've already gone through this, right? Approach potential supervisors. We talked about how to do that. So one thing you'll be asked to do is write a research proposal. That's very important. Many people think, oh no, once I write this, I'm locked into doing this subject, so I better get it right. That is not the case. The research proposal is not to decide what you're going to do research on. Although, of course, you're free to discuss that as early as you like with your supervisor. That's a valid thing to do. But writing the proposal does not mean you're locked into doing that. So why do we want you to write the proposal? Well, for 2 reasons. We want to check that you have a nose for figuring out a good research problem. This should show that you've got an ability to identify and understand a good research problem. And we want to know that you can explain why this is a good research problem. It's just your ability to nose out a good problem and your ability to explain why it's important. You'll need 2 referees when you apply. Those should be people who know your work well. And don't delay submitting the application. And there's no reason to do that, right? It's relatively straightforward to work out your research proposal, to get a couple of people to write strong letters for you and so on. There's no reason to delay. That's it. Are there any questions about that process or about anything else? Okay. So that was it. That's all I wanted to say for the pitch. I thought that would take 15 minutes, but it took 20. That's all right. So that means I've got 10 minutes to get to talk, or should I?
No, you can extend it.
So I'll just take a vote here. How many, hands up, how many people want me to be sure to finish after 10 minutes? 20 minutes? 30 minutes? 40 minutes? No hands are going up. You guys want to stay here for 5 hours?
20 minutes is good. 20 minutes.
30 minutes?
No, 40.
40 minutes?
Yeah.
Because that's around 5.5.
Well, I will aim for between 30 and 40 minutes. Let's see how that goes. Okay,
But feel free.
so that means we'll finish around 5:20, so that's okay for people?
Yeah.
Oh, I need you to get up the other thing.
It's
Oh,
right
it's right
there.
here. Very good. Okay, so I'm going to talk about 2 cultures of artificial intelligence. And roughly what this comes down to is, should you trust ML or ML? How many people understand that hilarious joke? So the goal of the talk is to get you to understand why that's very funny. Okay, the other reason that I'm doing this is, I've given this talk once before at a college in Cambridge, and my wife had to come along. She said, "That's the best talk you ever gave." So I was very encouraged by that. So Edinburgh has this huge festival that happens every year. There's an arts festival called the Edinburgh International Festival, and then there's a little thing on the edge of it called the Fringe Festival. Except now the Fringe Festival is about 20 or 30 times larger than the actual Edinburgh Festival. So it's a huge thing, and amazingly, so it's 20,000 different shows, and about 50 of those 20,000 different shows are academics doing stand-up comedy. So you get they get a real stand-up to introduce you, then you just do something interacting with the audience for an hour. I'm told. Prepare a talk. So this is my title. Chatbots are bullshit. My title was ChatGPT is bullshit. And they said, no, you can't use that. We might get sued. So the title is Chatbots are bullshit. So some of this will be based on the Cambridge talk, some of it will be based on what I hope to do at the Edinburgh Fringe. Tickets for the Fringe are very expensive, so you can consider yourself lucky. So let's start with this idea. Chatbots are bullshit. This is, right, I'm not exaggerating here. This is not hyperbole. Chatbots literally are bullshit, right? Let's look at the definition of bullshit, right? Bullshit means to bluff one's way through something by talking nonsense. So I picked this definition very carefully, because if you go through, there are lots of definitions that says lying about something. But bullshit is not lying about something. Bullshit is trying to sound convincing without regard to the truth. Right? And you can see these various early quotes using the word bullshit. You can see the 1967 one says, never tell a lie when you can bullshit your way through. Right? So very clearly, lying and bullshit are different. Right? So this is what's right. It's about something that sounds good without regard for the truth. Chatbots don't lie. Chatbots cannot lie. Right? This is a good property of chatbots. They cannot possibly lie. They can never lie to you. Why is that? Well, to lie means to deliberately not tell the truth. Why can chatbots not lie? They have no idea what's true. Right? There's just nothing in a chatbot that is about truth. Right? So, how many people know what the Hello World program is? No. You didn't bump into Hello World, okay. How many people know what? Oh yeah.
Everyone. Okay.
Oh, okay. You just don't know. You don't know how to nod. Okay. So Brian Kernighan, this man came up with that. It's an example for the C programming language. He was also one of the developers of. And in one of his textbooks, he gives this little exercise. And the exercise is take a huge chunk of text and count all of the triples of adjacent words that occur in it. So it began 7 years ago, and 7, that's the first triple, and 7 years is the next triple, and so on. And for each triple, you count up how many times it occurs. And then that is you generated, once you've got that data, you generated text by randomly picking, well, sorry, not randomly, you pick one of those triples based on probability, right? So the triples that have a higher number are selected more often than the triples with lower number. So you just randomly select a triple, and then you randomly, again, in accordance to how the counting goes, select the next triple that overlaps with your first triple. Right, so the last two words, the first triple must be the first two words of the next triple, and that gives you a bunch of triples you might take, and you choose at random based on the counts assigned to them, and so on. So if the text you give it is the Bible, which is easy to do because there are lots of online copies, it sounds a lot like the Bible. You know, every now and then it runs into a triple that only occurs one place, and another triple that only occurs, and for a while you just get a passage from the Bible repeated, but most of it has never been printed before, but it sounds a lot like the Bible. That's basically all that these different large language models do. That they're rather more sophisticated than that, but it's very much the same effect. And by the way, that's pretty much all I know about large language models. I suspect at least one of you knows way more than that and can improve on what I just said. Does anybody want to refine what I just said? Because you know more about this than I do. Basically, that's how they work. So it's just what words tend to occur together. So people have heard this term hallucination, right? So this was a very cleverly picked term because hallucinations are what you do if you have a brain, and then the brain malfunctions in a certain way. And so just by picking the word, it suggests that there's a lot of, you have to have a brain to hallucinate. So these ChatGPT things or chatbots must have, or large language models, whatever term you prefer, must have a brain. No, hallucination just means if you pick things just according to probability. Oh, the other term I've heard is stochastic parent. If you just pick words according to what other words are near them, then right, you have no notion of truth. You just have notion of what words are near each other. And of course, has everybody heard the story of the lawyer who got in trouble because he used ChatGPT to write his brief? And the brief put in references. And he just said, yep, that all looks great. And it did look great, right? Because it picks words that normally come with each other. So it looks right. So he just did that and then submitted it. And then the judge wanted to look up one of the references, and none of the references existed. There's nothing in that's going to make it choose references that exist. It's only going to say, well, these texts always have a list of references at the end, and they have citations, references, so I'll do all that. I have not checked. I don't even know if the references at the end match the references in the text. I would guess not, because there's no mechanism for that. You're shaking your head. Is that because you know and they don't match, or?
No, I'm not sure, but every time I saw it, it didn't match.
Right. So, right, it makes up very effective sounding stuff. That's it. And you have to be very careful because it can look like it's doing something very sensitive, like giving references for a legal document, but it's just made them up. So to make that sound fancy, they call that a hallucination. Right, the various AI products have been in the news a lot. Let me just review 3 of them. So one is just what we're talking about, large language models, with the GPT one in particular. And right, OpenAI has ChatGPT, and they're owned by Microsoft. And I don't know if people know this very interesting story, right? That OpenAI was founded with very high-sounding principles. We want to make sure that AI is safe for the public to use. We're very concerned about only developing AI that is safe and is in the public interest. But ChatGPT has been so successful, and Microsoft was one of the firms that invested in it, and the fellow who founded it, whose name, of course, escapes me, actually did something saying, well, I'm not sure that we're adhering to these principles, and there was a big to-do, and he was fired, and then the rest of the board that had fired him, they were fired, and he was put back in charge of the board, and Microsoft is in charge of everything now. Everybody's looking at them and saying, well, yes, so they're actually being sued by, of all people, Elon Musk, who said, well, wait, this was, when I put my money into this, it was on the grounds that this would be ensuring that AI is safe and is in the public interest, and now they're just interested in making money. So obviously there's lots of money to be made here, and when that happens, there's of course a huge pressure to move in that direction and away from let's make sure that this is safe in the public interest. So everybody, of course, wants to catch up with OpenAI. So Google, of course, has to have its own models. And they were trying to play catch up, and they advertised their own model, and they did a little example. And it hallucinated, right? It made something up. So the prompt was, right? A prompt is the piece of text you get that it uses at the beginning for generating everything else. And the prompt was, explain discoveries made by NASA's James Webb Space Telescope at the level a 9-year-old would understand. And it said the JWST took the very first pictures of the planet outside our own solar system, which is just made up. It's not true. First pictures were taken much long before that. But the right words in the right place. And as a result of getting that wrong, Google's stock price went down enough that the total value of Google went down by 120 billion in one day. So, the area that people take some attention to. But this isn't just used for words. You can do the same thing for art. So there's one thing called DALL-E. There's another thing called Midjourney. I happen to read a blog that uses Midjourney very often to illustrate things. So they had an article about Elon Musk, so they got to produce this illustration. Looks just like him. Captures him perfectly. So these are clearly also very useful tools. And you can see that this is moving in the direction of art. So again, we just went through the American film industry went on strike. And one of the things that happens, the screenwriters said, we want guarantees that you're not just going to use one of these large language models to generate scripts. So they've got some guarantees. We'll have to see how those work out. But this points to something, which is you can generate. So I've seen people say, "Look, soap operas are crap. This is just as good as the crap you get in soap opera. It will be fine." And I think that's true as long as you want something that's exactly that's only a mix-up of things you've seen before and has no actual originality. To talk about a different industry, programming, like that's something concerned to me, maybe a concern to you. And I've even seen distinguished talks sponsored by the Association for Computing Machinery on the theme of nobody's going to program anymore, it will all be done by large language models. And indeed, these can be. So I've also seen things by working programmers saying, this lets me program much more efficiently. I think that's probably likely to be true. But there are things like, look, you can just type in a prompt and get a web page. And wouldn't this be great? Any Joe off the street, you get a web page made automatically. I think for things like web pages of which there are already 1,000 in the world, it will do quite well at that because there's lots of text for it to copy from. But if you want to do something nobody's ever done before, that will be quite hard. So one thing, so people are talking about things like maybe robots are going to take over the world, like in all these science fiction films, and kill all of us. And everybody says, oh, we have to be very, very worried about this. And while they're being very worried about that, they're not being worried about the much more likely thing, which is they will fire all the people who write screenplays, they will fire all the programmers, and we will get kind of decent, okay screenplays and kind of decent, okay programs, as long as it's something that's been done many times before. And if you want something original, well, you'd need a person for that. But then you need a person doing this that goes into this field, and no people are going to go into the field if they're not being paid because it's all being done by large language models. So I think that's a very real problem to worry about. There's another and again, this might happen with art as well as with things like screenplays. And a second related problem to that is to get here already, right? The big companies building these models, how do they do this? They walk over the web and they train their models based on the data they find. And, well, wait a minute, all this stuff was under copyright. But the copyright laws were written long before any of this happened. So it's now the case, right? Somebody can type a prompt and say, write me a bestseller in the style of Barbara Carlin, and it will. Right? And people then put these, I have not seen this happening with Barbara Carlin, but you have people that are well known for writing certain kind of technical books. Somebody says, write me a technical book on this subject, in the style of this person, and the system generates it, and they put it up on Amazon with that person's name, and it sells. Right? If they use the facility on Amazon that you can get print on demand. So it's an automatically generated, automatically printed book, making use of somebody else's intellectual property. And it's not clear if our current laws are adequate for that person to sue for the theft of intellectual property or not. So the next time somebody says, all these robots might take over and kill us all, say, well, yeah, but that's off in the future. There's this other problem today that we need to be worried about. Another thing that's happened, of course, is self-driving cars. So the first two things I've talked about are large language models. The next one still falls under what's called machine learning. We're using all these probabilistic techniques, but it's not a large language model. It's a different kind of model. But there are lots of self-driving cars out there now. Tesla says, you can turn on this thing and it drives it. You still have to pay attention. But of course, there have been many accidents where people didn't. Let me show you one. So that's actual photo of the accident. I think the child's buggy there is the most poignant part of this. But we can actually show you the crash. Here we are. Oh,
Since it's a PDF, I don't think it's gonna click.
right. If I show you, if I could have used Keynote, I can now show you the video, but I don't have the video, sorry. But what the video shows is a car comes along and just stops for no reason whatsoever, right in the middle of this tunnel. It happens to be a Tesla that's got self-driving feature on, then 7 other cars pile into it. It's quite dreadful, except it's about there in the video, so it doesn't look as impressive as if it was right in front of you. But believe me, it's very impressive. You'd all be going, ooh, ah, over here. All right, so all of that comes under what's called machine learning. I'm a programming language person. Why do I have any right to talk to you about this at all? So when I first was asked to give this talk in Cambridge, I thought, well, this is for a general audience. They'll want to know about AI. I ought to talk about AI. What a fraud I am. I have no, this is not my background. I have no justification whatsoever for talking about AI. And then I thought about it for a bit. I realized that's not quite true. The man I learned programming from is this man, John McCarthy. So he was one of the people that attended the founding conference on AI in 1956. Some of the other names might be familiar to you as well. But Herbert Simon was actually my first PhD supervisor. I learned programming languages from John McCarthy because I took his class on Lisp. So Lisp was a programming language that was designed for writing the early AI programs, but was also very important as a programming language. To this day, it's one of the most widely used research languages. It's something called Scheme, which is a direct descendant of Lisp. And then this guy, Arthur Samuel, we'll see him again. Oops, I didn't want there. John McCarthy, Herb Simon, Arthur Samuel, we'll see him again in a few minutes. So, in fact, I was taught by one of the founders of AI. And I have another connection. This conference happened in 1956. I was born in 1956. So AI and I are exactly the same age. So the thing is, there are two strands of work in artificial intelligence. So when I took this class from McCarthy, he mentioned both of them. And what they were called back then were logic and heuristics. So logic is literally, you write down some formulas, you write down some implications. I remember what the old one was, if there's a potato stuck in the exhaust pipe, the car will not start. And then you could use this to work out, if you're trying to start, the robot could use this to work out. If it's trying to start the car and it doesn't start, maybe it should check for a potato in the exhaust pipe. So they had these logical formulas and they were just doing logical deduction. And this meant that in the AI field, there's a lot of interest in logical deduction. So one of the things that came out of this was McCarthy wrote some of the first papers on how do you actually specify what a program should do and prove the program is correct. This was about specifying a compiler for arithmetic expressions and then proving it was correct. And then there was this other strain, which was called heuristics, but it's also been called machine learning. So machine learning is about all of these things based on probabilities, basically. The large language models are an offshoot of this other branch, which is machine learning. And of course, it's abbreviated NL. But I mentioned Robin Milner earlier. He designed a programming language called ML. And it was, in fact, the programming language there because it was the meta language of a system for writing proofs, mathematical proofs. So it might be a proof that a program satisfies the specification, but there could be other kinds of proofs that you're interested in as well, like a proof of the principal theorem of the algebra, what have you. And ML-LCF, LCF was logic of computable functions. ML-LCF was one of the very first systems for doing an automated computer check proof, which is one of the areas that I work in. So now you understand why the title of the talk is so funny. So we saw this paper by McCarthy where he wanted to prove the correctness of a compiler for arithmetic expressions. That developed. So there were a number of these automatic proof systems. ML was one. There's an earlier one that was called AutoMath. And if anybody knows about De Broglie indices, which we use a lot of programming languages, those came from AutoMath. Then there were some later systems like COC and Agda. So using the COC system, Xavier Leroy wrote a thing called Concerts. This was a compiler for the C programming language that was proved correct. He didn't just write the compiler, he wrote a specification of C, and then he showed that the compiler he wrote met that specification. That was an optimized compiler. I've got a diagram here, right? These are all the different optimization phases used in the compiler. So that's pretty impressive. And you might wonder, does this make a difference? So at this time, there were researchers saying, how do we test a compiler for a language like for C? Well, there are lots of C compilers around. Why don't we generate programs at random, run them on all the compilers, and if two compilers get a different result, we know one of them must be wrong. So they did that, and they found hundreds of bugs in C compilers, but they found none in Concert. This is actually not true. They did find about 3 bugs in Concert. They were in the parser, which had not been proved correct. The bit that there was a tiny bit of the compiler that had not been proved correct, that had some bugs in it. Later, it was rewritten so the entire compiler was proved correct, and then they reran it through Concert, no bugs at all. So that's one example of the sort of things you can do with proof. Another example is, right, we all have our phones which have their operating system. It's iOS on an iPhone, or it's Android on an Android phone. But there's another one called SEL4, which is actually widely used in some phones. It's not widely used. It was designed to be secure. It was just designed and marketed as an operating system for a phone. But then these people went off and they said, let's write a specification of it. And let's do a new implementation of SEL4 that's as efficient as the original one, but is proved correct. They did all that. And the way they did it is, so here's the people who did it. There's the paper on it. The way they did it is near and dear to my heart because, well, first they wrote a specification. That was just in logic. But then they wrote a high-level implementation of the operating system. So this is the specification. This is the specification. And then they rewrote it in Haskell, language I've been associated with, the functional language. And then they proved that this bit of code matched this specification. And then they went off and they rewrote it in C to be more efficient. And then they proved that this C code matches this Haskell code. And then one member of this group is my colleague Liam. And for his PhD thesis, what he did is he designed a new language very similar to Haskell, but which keeps track of things like, well, this array, there's only one pointer to it, which makes it very easy to convert it into efficient C where you update the array in place. And so he could take something like this and generate something like this automatically from it. So we've come quite a ways in doing this, and it's still quite an expensive process, but it's actually now possible to talk about writing out a specification of a very complicated system and proving that something matches that specification. And I work in the, I do some consulting for a cryptocurrency firm. And if everybody knows about Ethereum, what you know is that problems in smart contract which are programs for Ethereum crop up regularly about every 6 months. There's some kind of exploit where there's some kind of problem, or that somebody then takes advantage of a bug in the program, or somebody even puts a bug in the program deliberately as a way of fooling everybody, and then literally hundreds of millions of dollars get lost through this error. So I'm quite keen. I think cryptocurrency might be a good place where people actually want to do proofs about programs. And as an example of that, the cryptocurrency firm I work for, they have a tiny language that smart contracts compile down into. And I, working with colleagues, have written a formal specification of that tiny language. And in fact, our specification was written in something called Agda. So I've mentioned ML, and then after ML came along, POC came along, and then after POC came along, Agda came along. So Agda is independently typed language aimed at being able to write both programs and proofs in the same language. And it was designed by people, so it was designed by people at Chalmers University. So that was important because there were people there who knew a lot about type theory, which is this idea of dependent types, which was largely developed by Per Mertenlof, who was a professor in Sweden. They were very familiar with his work. But also my colleague John Yu's work there, so they were very familiar with Haskell. And Agda is sort of the mixture of these two things. The way I think of Agda is what Haskell wants to be when it grows up. So I've ended up writing a whole textbook about Agda called Programming Language Foundations in Agda. And so the first half of the book is just, here's how you do logic in Agda. And the second half of the book is, okay, now we know how to write specifications. Let's specify something. And the simplest model of the programming language is the lambda calculus. So it goes through several variants of how you would specify lambda calculus in Agda. And what I'd like to do is take Merton-Love's type theory and do that in Agda, but that's an open research question. So let's finish up by coming full circle. If you work in academia these days, one of the things you're worried about is that students will just do all their homework, but ChatGPT will do the homework for them. So all of us have to take our homework assignments and give them to ChatGPT and see what happens. Because the simplest possible problem in my textbook. And said to ChatGPT, can you do this? It said, show that addition is associative. Your program should be self-contained. It said, don't forget to import the definition of equality. And it did all this. There it is, importing the definition of equality. There's the definition of natural numbers. There's the definition of addition. And yeah, there's a proof that associativity, that addition is associative. So that is that A plus B in parentheses plus C is the same as A plus B plus C in parentheses. It's a fairly simple proof, as you can see. And it did it perfectly. Oh dear. But what this really tells me is that there are lots of proofs of associativity of addition that ChatGPT has already scanned or stolen the intellectual property of, or whatever you want to say. So now I gave the next hardest problem for my textbook, which is the same thing, that now proof addition is commutative. So that's a longer proof. It is about this long, but this proof is wrong. So it gave me a wrong one, and I said, nope, that's wrong. Try doing a lemma, two lemmas, one that proves this and one that proves that. I got the lemmas absolutely right, but I put them together wrong. And so I kept trying to fix it. And so, like I said, right, why do you invoke lemma 2 in the first line of the subcase? The equality you want all step initially, you don't need a lemma here. Can you correct the proof? And it says, you're right. Thank you for pointing that out. We don't actually need to use lemma 2 in the first line of the subcase, since the equality we need follows definitionally. Here's the corrected proof. That gives another incorrect proof. And I went through several times and then gave up after a while. You get the lemmas, which are very simple, but even just putting them together, it couldn't do. So what did I learn from this? Well, first of all, I should feel offended because it means ChatGPT has not tried to steal my textbook. So otherwise it would have just copied it out of there. It's clearly, even for very simple problems, it's not doing very well yet. Right? It can basically only do stuff that it's seen lots of times. I mentioned, right, it is very helpful for programmers, but even programmers have to be careful with it long before ChatGPT blew up, there were already systems like this, a system called Copilot for aiding programmers from Microsoft. And Microsoft is so excited about this. Have you heard this, right? They've added a new key to their keyboard that says Copilot on it. This is supposed to be a big step forward. And indeed, these systems do seem very helpful for programmers, right? This is much better than trying to look something up in the documentation, right? You just pull something out and get the order of arguments, right? They give you a model to follow. So all of that is great. Of course, the way it works with this is, it scanned a huge number of programs already in GitHub. Some of those have security flaws. And yep, somebody did a study. Let's see what it suggests. Yes, it often suggests things with security flaws. So while it's very helpful, you also have to be very careful, right? And it's just whatever is out there, it will duplicate. If what's out there is stuff that has security flaws, that's what it will suggest to you. So you do need to be careful about that. But it will be helpful, and obviously this will get better, right? There's still but here's the interesting thing. This is what I want to finish on. So on the one hand, we've got logic, which is great, but you really need to be a specialist to do this. On the other hand, you've got these large language models that can generate things, and they can generate them at a suggestion from a person. So the thing is, I can immediately tell this is wrong by running it through Agda. If it ever gets it right, Agda will know, right? Agda checks the proof. So if you bring together these ideas, right? If you bring together ML and ML, what you can do is you can have the probabilistic system generate a proof, and your logical system check the proof. And at this point, so are we home free? It can do everything for us. Well, no, because what you'd want to do then is you'd want to specify what your program does, turn that into logic, and you'll have to check that. And you'll have to say, wait, do I believe that specification? Once you've got the specification, you can say, generate a program that meets the specification and generate a proof that it meets the specification. And then you can check the proof. So you can use whatever inventiveness or other relevant techniques can be powered by machine learning, and you can trust the results because it also gives you a proof it's correct, and you can check that proof. So that's clearly a way forward. I think lots of people are going to start looking at this. I've already heard several people independently propose this sort of thing. Somebody actually has a running system that works this way. It's for something much simpler. It's for recommending restaurants. So yeah, ChatGPT can give you a recommendation for a restaurant, but they're okay. But could end up recommending a restaurant that doesn't even exist. So what they did is they had a database of where are the restaurants, where are they located, what are the ratings people have given them, what kind of cuisines do they have. Turns out, so there's this little logical language. Turns out with very few examples, you can teach ChatGPT how to translate an English sentence into this little logical language. And you can teach it how to take something from this little logical language and translate it back into English. So they did that. And so you just type in English, and you just have a little dialogue with it, and then it gives you back a restaurant recommendation. But it's one that comes from the database. They did some measurements, and yes, this hallucinates much less, right? It's actually giving you information from the database. You might think it doesn't hallucinate at all because it's getting information from the database. I actually went through what they did, and there's one place where somebody says, well, I want a restaurant that does curry. I come back and says, yeah, this is a place, it's highly rated, it's well known for its curry. No, what the database says is they do curry. And what the database says is they're highly rated. And then ChatGPT elucidated. It's well known for its curry. So you have to take what it says with a slight pinch of salt, but you get much more reliable results by taking these two strands of AI, the heuristic strand or the machine learning strand and the logic strand, putting them together. So that's basically where I want to stop. I want to tell you just a wee bit more about how this, so it never got there. When I felt like interacting with this was ChatGPT is a perfect simulation of my nightmare student. Someone who's extremely confident, but knows nothing. And I can't say ChatGPT didn't learn anything actually, because at one point, it kept giving the wrong things. I kept saying, no, why don't you try this other thing, the way I would say to a student, and said, oh, I'm so sorry, blah, blah, blah. Here's the correct solution, and then we'd echo what I said, which doesn't do me much good. And then it would say, here's the correct proof, just like that, and give me another incorrect proof. So after a while, I got fed up, and I said, you keep telling me here's the correct proof, but it's not correct. And then the next time it did it, it went, oh, I'm so sorry, blah, blah, blah. Here's the next version. So it learned something. It said next version said corrected proof. But other than that, it learned nothing. It really just, these techniques were not able to cope with even this level of logical complexity. Now things will get better. You will definitely, people are already looking at using these techniques to generate proofs, and they will get much better. And the key point is proofs get checked, and you can check them using logic, not using the machine generation bit. So the machine generation bit can generate the proof, but then you check the proof that really is a proof. So then as long as you know your specification is correct, and that will be the hard part. That will be where people need to look at things. But as long as you know your specification is correct, if you've got a proof, you're done. You can trust that proof. So this is one interesting way forward for these systems. And I will stop there. Thank you for your time.
Thank you for the talk. And now we will be questions.
Yes.
One question is Prolog programming logic dense? If not, it doesn't have a future.
Does Prolog have a future?
Yes.
Prolog is very widely used. So it's a little bit, it's closely related to these things I've talked about. I could easily imagine it would be quite, in fact, the system I talked to you that did restaurant recommendations was essentially using Prolog as logic. So yes, Prolog definitely fits in here.
It has a future.
No, nothing has any future. Everything's going to be taken over by the computers that are going to kill all of us. Apart from that, yes, Prolog has a future.
Yeah, to add on that, I was reading a book about AI history, and as far as I understand, after the McCarthy started the whole first AI boom and stuff, there was that first AI winter, and then there was a time where logic-based and expert systems were like the biggest stuff in AI. But
So expert systems, they're right. If you've been around for a while, you see that there have been these phases.
Yeah.
Right. So there was a lot of interest in AI, and then in the UK there was this thing called the AI winter.
yeah,
Because a report had been written saying, "Oh, this is all nonsense."
by a big way in computer science, right? But my question was just that like
And then there were expert systems,
Yeah.
which were not so much logic-based, they were rule-based, so that it was actually more on the heuristic side,
okay.
but a little bit closer to logic. You indeed had these
Yeah.
rules, but the rules weren't logical rules, they were heuristic rules.
Okay. Yeah, because then I understood it wrongly, because I was gonna ask that, as far as I understand these expert-based systems, the problem was that it was hard to create rules for everything, because these kinds of chatbots and
Right, there was huge interest in expert systems, and then it got But, they were very successful at something. There
Yeah.
are, I believe, many existing medical diagnostic
Yes,
systems that
because they're
are
more
in use
specific, right?
and that are basically based on that idea of expert systems.
Yes. But do you think logic-based systems are scalable to be as general as these chatbots are?
That's
kind of my
scale to be
question.
as general as chatbots.
Yeah, because the
So-
thing is that as far as I understand, chatbots, they sacrifice being true by being probabilistic, right? They're stochastic patterns, as you said,
Right, so that they work over a very wide
Yeah.
range of things.
but they do it in a very
So I
inclusive
think
manner.
that what we will find, that the successes of logic and, for the successes of logic in combination with these systems, like the restaurant recommender, is that you'll be in a much more limited domain.
Yeah, that's what.
So I was reading an article the other day that was talking about, planning a vacation. Like, chatbots are great for this. And so we actually tried it out and, well, actually, no, they're not. People say they are, but they're not so good. So they know, it's like, it recommended, while you're there, you should see this festival, this festival, and this festival. But those were 3 festivals that occur at different times of the year.
Yeah.
You couldn't take one visit and see all 3. But for that kind of thing, definitely this logical approach would work. What I tried to show in my talk is that logic can in fact deal with very complicated systems outright. An entire operating system for a phone can be proved correct. So in terms of how much the logic can deal with, we're getting to the point where you can do quite well. Another example is another proof system that came along after Agda. It's called Lean. And it's now being heavily used by mathematicians to the extent that there was a Fields medalist, so that's the highest award in that fact. And he had a new theory that he was really interesting. He proved this theorem, but the proof was very complicated. He wasn't sure he believed his own proof. So he went to the Lean community. He said, can you specify and prove this with Lean? And with him helping them, they managed to do that. He now believes his own proof. So Lean is actually helping, this idea of proof system is helping working mathematicians. So logic can do a lot. The place where they intersect, it'll be a long time before we get to full generality.
Sure.
It'll mainly be, I think, for more specific things. Yeah.
You gave a simple example about restaurant recommendation that was used along with a logic specification. Roberto says a lot that programming languages are also software. So, do you see what's your opinion on the combination of these two, along with AI creating many programming languages, like software?
Oh, it's AI created programming language. Oh, taking over my job.
I write logical specifications or something that must be true for my language, it must be like safe or something like that. And the AI can generate specific parts of my programming.
That's an interesting idea. Okay, that's my next research project. So we have these things called domain-specific languages. And yes, it's not beyond belief that you might, what I would want to see, that's something that helps you spit out a specification for the language and an implementation for the language and a proof it's correct. And yeah, maybe you could do all that and then people could design their own special purpose languages, which would then, help with what he said in terms of, adding. So yes, that's a perfectly reasonable way forward, which I haven't thought of. Thank you for the suggestion.
In your opinion, it's danger to use GPT in higher applications.
Sorry?
It's danger to use ChatGPT in enterprise applications.
Okay.
Like select the statistics, Google, bad for my privacy.
So, right, Google and OpenAI and so on are all making these available as commercial products, and some people lever building them into various things. So what, I didn't quite follow your question.
If you it's dangerous or not?
Is what's happening now dangerous?
Yes.
So I referred already to, I think, are the two worst dangers. One being all this intellectual property has been stolen. It's actually being used to generate things that claims to be work by existing people. So that's obviously dangerous. We're going to need to come to some accommodation. And I talk about the other danger I see, which is that in some domains, maybe in artwork, maybe in writing soap operas, maybe more generally for entertainment, you will find more and more of these systems, which means that we will have less and less originality. And we might reach a point where we can't get the original solutions anymore because it's not economically viable to train in those areas. I think that's something that we have to be seriously worried about. I'm much more worried about that than worried about robots supplanting humanity. So that I think is the place where we need to be looking at is these different applications and how they're displacing people, and there will be applications where you don't need that much originality and where they might be helpful. But I think we need to consider this very carefully. I think, and what's happening is, the companies are just going out and doing it, and then they're saying, we've done it. I think what we need is for the different national legislatures to go back and say, I think we need some retroactive changes to copyright law so that people get recompensed properly for the work they've done that's fed into these systems. I think the companies that are making so much money from this are so powerful that may not happen. That's a big risk. One of the dangers we need to look out for.
Thank you again for the talk.
Okay, thank you very much.
Thank